There's already a video I uploaded to Edmodo, which is technically the first video on this section. We're going to do another video. I would watch that first video to get a better understanding, but this one in itself will help you understand everything you need to know in this section. So on the first video, I explained how to solve a radical equation. This is the final section of Chapter 6. We're going to have a Chapter 6 test on Friday. So please let's understand this last section right here. We're going to be solving radical equations, and the steps to solving a radical equation. The first one is to isolate the radical. So if your radical is not by itself, let's get the radical by itself. Once you have it by itself, you get rid of that radical by applying an exponent to both sides of the equation. So if you do have a square root, you would apply the power of 2 on both sides of the equation. If you had a third root as a radical, you would do the power of 3 on both sides of the equation to get rid of the third root. If you had the fourth root, you do the power of 4 on both sides of the equation. So getting rid of a radical, it's really simple. Just whatever root you have, you apply that power to get rid of the radical. And then step 3 is to check your answer. Why did I say Sorry. Let's just scratch that out. Check your answer. And how do you check any answer? You just plug it in, right? Just plug it in and see if it works. So I want to pause it right here. Please copy down these steps, and then we'll practice with the couple. Okay, guys, so I hope you copied down those steps. I hope you understand the steps. Now we're going to show you how these steps work to solve this equation that has a radical in it. Okay, so step 1 is to isolate the radical. Here's the radical. Is it by itself on the left side of the equal sign? No, there's a plus 6. So what do? Subtract 6, that's right. Let's get rid of everything and leave the radical. So you're going to have the square root of x minus 4 equals 10 take away 6 is 4. Okay, so step 2, after we've isolated it, it says get rid of the radical by applying an exponent to both sides of the equation. So because we have, what kind of root do we have here? Square root. So because we have a square root, we will apply, actually maybe I should do this in red since the step 2 is in red, apply the second power to get rid of the second root. And what you do to one side, you must do to the other side. So what do we have left? No more root. The square and the square root, they undo themselves, and you end up with the x minus 4 equals 4 squared is 16. And then you just solve the equation the way you normally would. Plus 4, you're going to end up with x equals 20. Now we still need our third step, which is check your answer. So you need to take that 20 and plug it back in and actually do the math. 20 take away 4. What's 20 take away 4? 16. And what is the square root of 16? 4. And what is 4 plus 6? 10. So you see how it worked? We've double checked it. We're 100% positive we got this right. Now, before we move on, I want to stick with step 2. Step 2 says get rid of the radical by applying an exponent on both sides of the equation. Why did I write that instead of saying to get rid of a square root, you square both sides of the equation? We're not always going to have a square root. We might have a third root. What would I have to apply to get rid of a third root? Power of 3. If I had a fourth root, power of 4. Fifth root, power of 5. So that's why I'm saying, bless you, to get rid of the radical, you have to apply the exponent of whatever that radical is. So if you have a fifth root, apply the fifth power. If you have the third root, apply the third power on both sides. Are you with me? Cool. Anyway, if you check out my first video, you'll see other examples. I will do some more examples. Let's actually go to the book itself. Let's look at one that doesn't look like a radical. Take a look at example 2 on page 430. Thank you. So example 2 on page 430. You might want to jot down this entire equation in your notebook, and I'll explain or I'll show you how the book does it. As a matter of fact, guys, it's a good practice to whatever section you're on, get the book, open up to that section, and look at the examples of the book. That's how you're actually going to learn in college, right? You're going to look at the examples, you're going to make sense of them. That way you'll be able to do them on the homework or the practice or the quizzes. So right here, they give you this problem. Now, what is step 1 that you guys copied down? What's step 1? Isolate. So isolate my radical. What? I don't have a radical. Yes, I do. Where's my radical at? Yeah, it's as a rational exponent. This is really the third root of this, right? So I need to isolate this. I need to get rid of the multiplication of 2 and the minus 4. What do I get rid of first? The 4, the minus 4. So you would go plus 4 and plus 4. And you know what? I'm writing on the book right here, but that's what they do. Here's your original equation. And as you can see, they add 4 and add 4. That's why there's no more minus 4. And that's why this 0 plus 4 became 4 over here. So if you're doing this fresh, yeah, you're going to add 4, and you end up with just this. I still don't have it isolated. I have the multiplication of 2 out here. I need to get rid of that multiplication of 2. What would I do? Divide by 2 to cancel it out. Divide by 2. And 4 divided by 2 is 2. That's how they get 2 on the next step, right? So that is step 1, isolating the radical. Even though it's a rational exponent, it's the same thing as a radical. We have isolated it. What is step 2? Apply a power, apply an exponent to both sides of the equation to get rid of that radical. So what exponent will get rid of the third root? The exponent 3, right? So let's do the power of 3 and the power of 3. And as you could see, that's what they do right here. They put the power of 3 there and the power of 3 here. And we know that when you have a power to a power, you multiply 1/3 times 3 becomes 3/3. It cancels out. So what do we end up with? Just with 6x minus 3 equals 2 to the third. We could actually do that. We get 8. So that's what they get right here. 6x minus 3 equals 8. And then they go plus 3, they get 11. Divide by 6, they get 11 divided by 6. Now this is their answer. This is our answer. But step 3 that you just copied down says you must check your answer, because not all the time is your answer going to be the final answer. You got to double check it. So when we go back to the original and plug in 11 over 6 right in here, imagine, I'm just going to write it. Plug in 11 over 6. What happens with the 6 and the 6 when you multiply the 6 with the fraction 11 over 6? They cancel out. So the 6's cancel. You end up with 11 take away 3. What's 11 take away 3? 8. And we really have 8 in this mess. 8 right in here. The third root of 8 is actually 2, right? The third root of 8 is actually 2. So I really have 2 right here times 2. 2 times 2 is 4. Minus 4, it does give me 0. I double checked that. I didn't show my work double checking, but you need to double check, because sometimes it will not give you a true statement, which means that the answer, if it wasn't a true statement, that would be an extraneous solution. So it wouldn't have an answer. What do you guys think? I hope we get it. So again, if it didn't work, you would say no solution. And it does happen. I think on the homework it happens a couple of times. So make sure you test your answer. Should we do another? Okay, so on this one, here's the book example. You could copy it down over again. But the bottom line is step 1 is to isolate your radical. So what do I do to isolate it? Add 6 plus 6 cancels out, plus 6. My new inequality is, there it is, 3 times the 4th root of 2n plus 6, close parenthesis, equals 6. I still need to get rid of this 3. What do I do? It's being multiplied by 3, so I need to divide by 3. So I'm going to end up with the 4th root of 2n plus 6 equals 2. So I've done step 1. I've isolated the radical. Step 2 is to apply an exponent on both sides to get rid of that radical. So what exponent am I going to put right here and right there? Power of 4, that's right. So when I apply the power of 4 and the 4th root eliminate, and you end up with a nice simple 2n plus 6. No more roots, no more powers, just 2n plus 6 equals 2 to the 4th. That works out pretty nice. 2 times 2 is 4, times 2 is 8, times 2 is 16. Did I do that right? Yeah. Sorry. And now we could solve that. Subtract 6, 2n equals 10. That means that n equals 5. That's our answer, but we did have step 3 that says test your answer. So if you were to plug in 5 right in here, it will work. 2 times 5 is 10. 10 plus 6 is 16. The 4th root of 16 is actually 2, right? 2 times 2 times 2 times 2 is 16. So this whole thing equals 2. And then 3 times that whole thing, 2, is 6. And 6 take away 6 really is 0. If I did show my work, it would double check it does work. So it's important to always double check. So I hope we understand we first need to isolate the radical and then get rid of the radical by applying a power to both sides and then solving and of course testing your answer. Now there's one more section to this section. That didn't sound too well, but solving inequalities is different than solving radical equations. So what is the difference? Well, they give you some weird looking steps right here. Step 1, if the index root is even, identify the values of the variable for which the radicand is non-negative. I said, what? Sounds crazy, right? What they're really trying to say is, if you have an even root, then you're going to have to set the inside of that radical to be greater than or equal to 0. Okay, so we're going to get a moment to copy this down in a little bit, but before you copy it down, let's understand the difference between solving regular radical equations compared to solving radical inequalities. So let me go back to here, and here is my first example from the book. I would jot it down in your notebook if you want. You're actually going to be doing two problems. You see, the difference between an equation and an inequality is an equation, you get an exact answer like x equals 5. And on an inequality, you're going to get an area of answers like x is greater than 5. It could be 6, 7, 8, 9. It could be 1,000, right? Or less than 5. It could be -2, -1,000. So when you have inequalities, you're talking about an area of answers. When you have an equation, you're talking about a specific answer. So because we're talking about an area of answers, and because we have a square root, the very first thing that we need to be careful for is not having a negative in here. If this whole thing equals -1, or if this whole thing equals any negative number, what happens when you do the square root of a negative number? You get I, you get imaginary. You don't even get anything real. Okay? So that's why step 1 of solving a radical inequality is to get your inside radical value, the 5x minus 10, and set it to be greater than or equal to 0. You see, I need this to be greater than or equal to 0, because if it's negative, I end up with imaginary. It doesn't work. Okay? So you're actually going to do two problems. You're going to set the radicand value, this value inside of the radical. You set it to be greater than or equal to 0. You solve it, you get an answer. And then you go back to the whole thing, and you solve it, and you get another answer. So, once again, when you have a square root, a fourth root, a sixth root, an eighth root, a 10th root, if it's an even root, you need this to be greater than or equal to 0. Why? Because you cannot do the square root of a negative value. You cannot get a real answer. You get imaginary answers. If it's a power 4, it has to be positive. It can't be negative. If it's the root, I said power, if it's the root of 3, then it could be negative. Because we know that we could actually do the third root of -8. The third root of -8 is what? -2. It's not imaginary. It's actually -2. -2 times -2 times -2 is -8. So you could do the third root of a negative number. You could do the fifth root of a negative number. But you can't do a square root of a negative. You can't do an even root of a negative. Does that make sense? Anybody? All right, 2 people understand? So if I have an even root, I need to state that this inside value has to be greater than or equal to 0, and I will get an answer. What answer do I get on that one? Plus 10, 5x is greater than or equal to 10. Divide by 5. I get one answer. X is greater than or equal to 2. That's one answer right there. Okay, that's an area of answers. And then after I get that one simple answer by putting this to be greater than or equal to 0, then I go back to the whole thing and solve the whole thing. How do I solve the whole thing? What's step 1 on solving a radical equation? Isolate it, right? So let's get rid of this 3 by subtracting 3 and subtracting 3. I'm totally out of space here. I'm just going to do it up here. So I'm going to end up with the square root of 5x minus 10 is less than or equal to 8 take away 3 is 5. Are you with me? What do I do to get rid of that square root? I apply a power. Which power? 2. Come on, people. When I square root a square, or when I square a square root, it eliminates, and you end up with just a nice, beautiful 5x minus 10, less than or equal to what? 25. Then we're going to solve this guy by adding 10. We end up with 5x is less than or equal to 35. We divide by 5, x is less than or equal to 7. So there's our other answer. X is less than or equal to 7. So on my notes that we're about to copy down, step 1 is if you have an even root, you got to set it to be greater than or equal to 0. That's what we did. Get an answer. Step 2 is to go back to the whole thing and solve it, get another answer. And step 3 is to test your answers. So the best way to test these answers is to do a number line, do a quick sketch of a number line, and 7 is over here, and 2 is right here, and let's say 0 is obviously over here outside the 2 and the 7. So if I take a look at this guy, it says x is less than or equal to 7. So less than or equal to 7 would be this way. And this other one says x is greater than or equal to 2. Greater than or equal to 2 is that way. So where are my answers at, according to this? Between 2 and 7. So because the areas are between 2 and 7, I want to put x in the middle, 2 right there, 7 right there, the inequalities like so. And there's my compound inequality answer. Now, it's always a good idea to check your answers. How would I do that? By testing a value like 0, it won't work. By testing a value like 4, it will work. By testing a value like 10, it won't work. Okay, but as you could see right here, it overlaps. This is where your answers are going to be. If I pick any value in there, it will work. So like, give me a number between 2 and 7. 5. If I plug in a 5 right here, 5 times 5 is 25. 25 take away 10 is 15. The square root of 15 is a little bit less than the square root of 16. So we're talking about like 3.9. 3 plus 3.9 is going to be 6.9. And 6.9 is definitely less than or equal to 8. So it is a true statement. If I pick any number on the outside like 0 or like 10, it's not going to work. Okay, so that's testing your answers. So now that you've seen the example, let's now jot down these steps. Solving radical inequalities. Step 1, set inside of radical to be greater than or equal to 0 only if you have an even root. If it's an odd root, you don't have to do step 1. You just solve it the way you normally would. Okay? And then, of course, solve. Okay, so once again, set the inside of the radical to be greater than or equal to 0 only if you have an even root. If it's an odd root, you don't have to do step 1. You just solve the entire inequality the way you would an equation. Okay. But if you do have an even root, you set it to be greater than or equal to 0, you solve it, you get an answer, and then you go back and solve the entire inequality to get the other answer. And step 3 is to check your answer by testing your values. You might have to write it as a compound inequality the way we did on that example. Or maybe they're apart, you would leave it with the word or, separate. Or they might be like going in the same direction. And we could go over an example of that in a bit. Okay, so let's go to our actual worksheet. This is what we're going to be doing for homework, 1 through 27 odd. Let's jump to inequalities, the ones we were just doing right now. So if I take a look at, let me pick one that's kind of weird, like number 26. It's an inequality. So it is an even root. So I know that I need this to be positive. So the first thing I should do is write that the 2a minus 3 needs to be greater than or equal to 0, because if it's less than 0, it's going to be negative, which means that the whole thing becomes imaginary. Does that make sense? So that's step 1, where we set it to be greater than or equal to 0 and solve. If I solve, I get a plus 3, 2a is greater than or equal to 3, a is greater than or equal to 3/2, okay, which is 1.5. And then the other one is to go back to the original and actually solve it. So how do we solve this? You want to isolate the radical. It's already isolated. There's nothing on the outside, nothing being subtracted or added at the end. So I need to get rid of that square root by doing what? Applying the power of what? 2. Power of 2. Power of 2. So I end up with 2a minus 3 is less than 25. Add 3, I end up with 2a is less than 28. Divide by 2, a is less than 14. So I have my two answers. A is less than 14 and a is greater than or equal to 3/2. So if I think about this answer on a number line, sorry, this one's not special. I thought that it would be a special situation, but it's just a regular inequality. Here's 14, 3/2, that's really 1.5, which is right there, which means that 0 is over here before the 3/2. If you test any value on the inside, it will work. If you think about this, x is, or a is greater than or equal to 3/2, greater than or equal to 3/2 is to the right. A is less than 14, that's to the left. So our area is obviously right here in between. So any value you pick in here will work. Any value that you pick out here will not work. I wanted a different one where we didn't get the area to work like that. Which one? Number 23, that's a really easy one. Let's do that one. Step 1, if you have a square root, is to set this to be greater than or equal to 0. So if you set a to be greater than or equal to 0, that's the actual answer right there. Yes? So that's one answer. Let's find the other by actually solving the whole original inequality. Let's isolate the radical by dividing by 3. By dividing by 3, you're going to have the square root of a is greater than or equal to 4. How do I get rid of the square root? Square. How do what I do to one side, I do to the other. I end up with a is greater than or equal to 16. That's my other answer. So this one's a special case. I should have done this one. I'm sorry. Why do I say it's a special case? I want to do 0 right here and 16 over here. And when I think of a is greater than or equal to 0, greater than or equal to 0 is to the right. And when I think a is greater than or equal to 16, that's also to the right. So it's not an area that's together right here. There is no overlap right here. It's both going in this direction, so the overlap is over here from 16 on this way. So your answer is just this guy. You don't write it as a compound inequality. Of course, if you tested a value, like if you tested a number between 0 and 16, like let's say 9, 9 works out pretty good. The square root of 9 is 3, and 3 times 3 is 9, and that's definitely not greater than or equal to 12. You see how it doesn't work? Any value in here will not work because the overlap is over here. If you test any value that's greater than 16, like 25, square root of 25 is 5, 3 times 5 is 15. 15 really is greater than 12. So over here it doesn't work. It does work. Right here it does not work. So your answer is only this one, not that one. So you have to test your answers to see where your answers are at. So again, they end up overlapping. See right here is only representing one of them. Right here is where they start overlapping. So this is where your answer is really at. And again, if you test any number like 25, you'll see that it does work. If you test a number like 9 that's in between, it doesn't work. If you test any negative number, it's not going to work because a negative is imaginary. Anyway, that's as hard as it gets, where you actually have to think of the number line. The whole first part of this homework is easy because they're all equations. So you just isolate the radical. So number 3, isolate the radical. You have the square root of 2p equals 7. Then you get rid of the radical by applying a power. So you have 2p equals 49. And then you divide by 2. P equals 24.5 or 24.5. There's your answer. If you test it, will it work? Well, 2 times 24.5, that's 49, right? Square root of 49 is 7, and 7 plus 3 really is 10. You double checked it, it worked. So the whole first part is really easy. It's not till the second part down here where you have inequalities that you actually have to think of the number line and test values to see where your answers are at.